This is a tutorial about one-step stoichiometry. So here's our problem. Our problem is ammonia, which is widely used as a fertilizer and in many household cleaners. And we're given the question, how many moles of ammonia are produced when 6 moles of hydrogen gas reacts with excess nitrogen gas? So the information that we need to look at is what we are given, the quantity we're given, which is 6 moles of hydrogen gas, and what we're looking for, moles of ammonia. The reason the problem talks about excess nitrogen gas is it's telling us that we need enough nitrogen gas to react with all of our 6 moles of hydrogen gas to get our product. So with stoichiometry, you must have a balanced chemical equation, so that will be the first thing that we do. So we take a look at the equation and we balance it. Okay, so a balanced chemical equation means that the number of atoms of one type is equal in number to the number of atoms of that same type on the reactant side and product side. So there's 6 hydrogens here, 6 hydrogens here. All right, so now that we have a balanced chemical reaction, the coefficients are going to be our ratios. So for every 3 hydrogen gases and 1 nitrogen gases, you can make 2 ammonias. This is important because those ratios are going to be used every time you do a stoichiometry problem. So remember, in stoichiometry, the mole ratios comes from the coefficients of the balanced reaction. In our problem, we're given 6 moles of hydrogen gas, and we're looking for moles of ammonia. So the coefficients that we need to pay attention to are the 3, because we are starting with hydrogen gas, and the 2, because we are trying to end up with ammonia. And therefore, in this problem, we can ignore the nitrogen gas because it's in excess. So the first thing that I always do when doing these problems is write out my given, which is 6 moles of H2, and then figure out what I'm solving for, which is my moles of ammonia, which is NH3. Now take a look. We are changing substances. We're going from hydrogen gas to ammonia. So that tells us that we need to be using a mole ratio. In stoichiometry, the mole ratios always come from our coefficients. So we are going to take those coefficients and write out a ratio. For every 3 moles of hydrogen gas, 2 moles of ammonia is produced. All right, now take a look at the other units. We were given moles of hydrogen gas, and we want moles of ammonia. Because we are going straight from moles to moles, we do not need molar mass. We can just use our mole ratio, which is why this is a one-step problem. Because it is a mole ratio, we can convert from moles of one substance to moles of another substance. So now we set up our dimensional analysis. All right, so we're going to start our dimensional analysis with our given 6 moles of H2, and then we're going to draw our times and our line for our fraction, and we are going to use the mole ratio as our fraction, our converter, but remember, the unit that you start with goes on the bottom in the next step because you are trying to cancel out this unit. We're trying to cancel out moles of hydrogen gas. The unit that you are solving for, in this case it's moles of ammonia, will go on the top. That's where we want to put it. So whatever you start with, moles of hydrogen gas, that is going to go, that unit is going to go on the bottom in the next step. Whatever you are solving for would go on top. And then we just plug it in to the calculator. 6 times 2 divided by 3, which would give us 4 moles of ammonia. And that would be how you do a one-step stoichiometry problem.